Welcome back to Retro Depot. Today we're going to be taking a look at how you can convert an ATX computer case to being an AT computer. Problem is with collecting old computers is a lot of times we have to make do with what we can get our hands on. And one of the problems that I have personally here in Oklahoma is finding suitable cases for AT computers. I've got several AT motherboards. I've got 486s, 386s, some Pentiums, but the problem is I don't have any AT computer cases. I've tried looking around, I've gone to yard sales, I've gone to the flea markets, checked places like Craigslist and even Facebook, but yeah, you just can't find AT computer cases here in Oklahoma. And a lot of that is due to a couple problems. First being is that Oklahoma is a relatively poor state. Its population just didn't have a lot of money back in the 80s and 90s when these computers were popular, so there weren't a lot of these cases to begin with. Like many other parts of the United States, the computer revolution didn't really start here in Oklahoma until the internet became readily available. And at that point, people began buying home computers, PC clones at the time, through places like Dell, E-machines, and things like that. There weren't a lot of computer stores in the rural areas, so you either had to go to a big city, usually out of state or in either Tulsa or Oklahoma City, in order to buy a computer, or you were essentially ordering online or out of a magazine. I say online, probably out of a magazine. So the problem was there wasn't a lot of the AT computer cases, at least the tower cases, here in Oklahoma to begin with. Now, there were plenty of ATX cases, because ATX form factors began getting kind of popular around the time of the Pentium 1 to Pentium 2 shift. So you did start to see those types of computer cases. However, without having them here, we're essentially forced to buy them online. And the problem with buying online, as I'm sure many of you have found, is that people seem to think these computer cases are worth their weight in gold. And while they are collectible, there's not that much of a price difference between what an ATX case is going for and what a AT case should go for. However, looking online, I oftentimes see computer cases for anywhere between $70 to $100, but then they also have a shipping cost of anywhere between $40 to $70. So you may end up spending anywhere between $150 to, in many cases, up to $200 just for an empty computer case. And that's a real problem, because I just have a hard time accepting that those computer cases are worth that. So that said, I started taking a look at how I can convert a older AT case that was, kind of an off-white or a beige, into being something that I could use for a AT build. And to my surprise, there was not a lot of information out there. Maybe my Google Kung Fu is just not as good as some of yours, but I couldn't find a lot of information on it. And so I decided that I was going to tackle one problem at a time. And that led me to doing this video, because I wanted to document what I had to do in order to make this work for me. So the computer case that I have here is actually completely built at this point. I'm turning it around so that we can see a couple things. First, you can see that I do have an I/O shield here, and I'll touch base on that in a little while. But it is one that's been fitted with a single hole for the keyboard connector. And I do have a couple I/O cards here, but the one thing I do want to point out is that I've got a total of, I think it's 7 slots here. You'll want a tower with at least 7 slots. And the reason for that being is because most of your AT boards are going to have at least 7 slots. Some of them may have more, but we want at least this many because most of your AT boards that you're going to find are going to have at least 7. So we want to give ourselves some space. And with some of these boards, we may even have to make some further modifications to the I/O shield as well as the case in order to fit them. But that's the big thing there, is we want to make sure that we go from, you know, a form factor that's going to be able to fit a 7-slot or a 7-slot ATX motherboard into something that's going to be able to house a 7-slot AT motherboard. Now, the second issue is obviously the I/O shield. With these, and of course, if you haven't ever really paid attention to the back of an ATX computer, this is what an I/O shield looks like. And it essentially sits over the back of the motherboard and basically just makes everything look pretty. AT motherboards originally just had a hole, and the hole was just for the keyboard connector. So we have to essentially fill this void that would normally be here. Now, I started to design something in CAD to be able to 3D print. However, once I started looking for dimensions, I very quickly ran on a post on Vogons, which, if you're not familiar with the Vogon site, it's video games on new systems or something along those lines is what it stands for, but they actually have a lot of people that have posts dedicated to older hardware on there. And there was a guy that has actually already designed a I/O shield for this. Now, I had to make some modifications to it for a couple reasons. My printer is pretty well dialed in, and what I mean by that is I essentially took my old printer and reprinted it. Or, well, I'd say reprinted. I revised it and put a new motherboard in it. You know, entirely new computer from the ground up. It's essentially with the exception of the frame. And I've dialed it in. I can measure my test cubes and everything else, and they're on the money. However, whenever I went to print this I/O shield, it was too big in both the X and Y axis. So, that said, I had to resize it to about 99% on the width and about 98% on the height. And the reason why is so that it would actually snap in. And the way I did that, it actually allowed me to center where that keyboard connector hole was. The other issue that I had with this particular case is this particular case does not appear to have been, doesn't appear to have been quite to spec. And what I mean by that is originally there was a couple washers placed under each standoff, and that was essentially so that it brought the motherboard up high enough so that it aligned with both the I/O shield as well as the places for the cards to actually go in for their brackets. So this case was not quite to spec. Now, believe it or not, the brackets would fit, but they were standing up just a little bit too high where you would screw them in. So that told me that as far as the brackets were concerned, they were right, but where the I/O shield placement was, it was off. So I had to go in and further edit this I/O shield here to essentially have a little bit larger of an opening and placed a little bit further towards the back of the computer case. Once I did that, it worked perfectly. Haven't had any problems with it. Keyboard connector goes in just like it should. But that's the big issue. Now, another problem that we're going to have with building a computer like this is going to be the power supply. AT power supplies are not super common here in Oklahoma, and they're becoming less common throughout the United States, and the ones that are out there are aging. So they're getting old. They may fail for a multitude of reasons. Certainly many of those can be repaired if you know enough about power supplies in order to repair them. But you may be limited on how many of those you're going to end up having. So it would be nice if we could actually replace this with something that's more modern. And the power supply that I'm using here actually came with this computer. Now, this computer case, it was, I believe, made in 2004. I believe that's what the quality control stamp on the inside of the top piece here says. So it's about 17 years old at this point, but the power supply still works well. It's within spec. So I wanted to find a way to convert an ATX power supply to an AT form factor. And what I mean by that is the physical connections are different. And the second problem is that the AT power supply actually has 4 cables that go from the power supply to the front of the case. And those are actually mains power. And you have a simple switch that, much like a light switch, just turns the power on to the power supply. However, with an ATX power supply, you actually have a power signal that's shorted to ground in order to turn the power supply on. And that's very different when it comes to operation, because typically an ATX computer would have a connector on the board itself. Let me see if I can find it here. I'm not seeing it on this particular board, but they typically have a jumper that you would connect that power connector up to, and whenever you press it, it does a monetary off, and it essentially turns the power supply on, because the motherboard is always drawing power from the 5-volt standby power. However, on a AT motherboard, we don't have that. As a matter of fact, the only power connectors that we actually have are going to be for the power supply to connect up to it in the first place. So we needed to find a way of getting around that. Now, there's 2 things that you will need. The first being one of these adapters. Now, what this does is it takes an ATX 24-pin power connector, and it's a female version of that. It allows this to basically snap onto the cabling for the ATX power supply. And then it provides you with your AT power connectors, P1 and P2, or P8 and P9, whatever they are actually called. And then it also gives you 2 of these little wires here. Now these are actually meant to connect up to the power switch that you typically find on AT computer supplies. You know, it's just got a couple of these little tab connectors here that connect up like such. But the problem is, with these computers, they don't have that. What they actually have is a connector that's like this, with a little switch that's been soldered onto the end. Now, you can also buy replacements, and these are 8 by 8 by 8. Let me see if I can get that a little bit closer. And essentially, the ones that I've bought here, instead of it being a monetary switch, these are locking. So if I press down, so we can essentially hold this to ground, just like it would be on a AT power supply, by essentially removing the switch and you know, essentially adding new wires and soldering this up and reinstalling it in the front panel. So that's the 2 keys for the power supply conversion portion of this. Is we want to make sure that we have one of these, and of course I'll stick all the links below, at least to, you know, products that are available at the time that I release this video. But we're going to want one of these, as well as one of these on-off switches, and you're going to need a soldering iron and a little bit of extra wire, or you can actually reuse the wire that's on this, because this little switch is just going to snap into the front panel. I'm probably not going to take this off and show that to you, because it requires actually doing a little bit of work to get it off there. But it's a pretty easy mod. You just have to remember the switch that you're looking for is 8mm by 8mm by 8mm. So, that said, the next thing that you're going to want to take into consideration is how to mount the motherboard into the computer case. Now, the footprint for the ATX motherboards is actually very different from the AT motherboards. If we were to take a look at these 2 motherboards, we can see that there are some similarities. So, for example, there's 2 holes that are right here, and those 2 holes correspond to these holes right here. There's also a couple offset holes on this particular motherboard and another one up here. Those typically line up. If you take a look here, the one that was on the top of the other board, where it lines up is here, and then it has another one here, very much like what you see here and here. However, each one of these AT motherboards, depending on what machine it came out of, may have a footprint that's a little bit different. So one of the things that you're going to want to do is to take all of the standoffs out of the tray of the motherboard, or out of the case, the tray of the case that is. And you're going to want to put them into the holes that correspond with the AT board. Now once you've done that, you can actually just take a pencil, I'm using a screwdriver here, but stick it through the holes that don't line up and just draw a little dot onto the tray portion of the case. Of course, once you have your shell off, you'll be able to get to both sides of this, and that'll be important because one of the next things that we're going to want to do is going to involve a drill and tap set. Now you can buy these pretty cheap. The handle itself is usually $5 to $10, and then you can buy the individual sizes for the drill and the tap. Now the drill and tap kit actually costs about $5, at least at Lowe's. If you're overseas, I'm sure you have some type of hardware store chain that you can go to and buy these things fairly cheap. But once we have located where these holes need to be, we need to drill and tap for 6/30 seconds. And it's actually quite simple. As a matter of fact, you don't even have to have the tap handle. If you go very slow with an electric drill, you can drill the hole with the drill and then turn around and chuck the tap up in it and go very slow to essentially thread that in there and do that. It would be nice if there was some type of swage mechanism that I could find that would actually, you could drill undersize and then swage that hole out so that you'd have a little bit more of a neck for those threads. But I haven't been able to find anything like that. So what we're doing is going to just be enough to hold a standoff in there. But once we have our standoffs in our proper location, at that point we can mount our motherboard in, we can place our I/O shield in and make sure that it's properly aligned, and then that's most of it as far as the hardware is concerned. The next thing that we have to take into consideration, like I mentioned before, is the power supply. Again, you will need an adapter, one of these switches, because these switches seem to be pretty universal. I've taken a look at many computers over the years, and there's a ton of computers that actually use this 8x8 switch. Now obviously there may be some that are different. I've seen some that actually use a 7x7x7 switch, but the 8mm by 8mm by 8mm seems to be the most common. Now that said, the next thing that you need to make sure that you do is wire this thing all up so that it's going to work correctly. Now, most of this is going to be pretty common sense. Obviously, you need to make sure that you go black to black when connecting to the motherboard. We, in this particular build, have taken the original cabling for the power switch connector, chopped the end off, soldered it, and shrink wrapped it to the green and black wires on this connector, and then placed it in the front panel. The only thing that is not connected up is the key lock, the turbo switch, as well as the turbo light. We don't need those, but it's nice to have, and I'm actually planning on 3D printing a front panel bay cover that's going to have those items in there, as well as a turbo LED, speed indicator, if you will. I'm going to do a separate video on that once I get that done, because that's still in the design phases. But this is essentially what we have, and I'm actually very happy with this build. The only thing that I dislike about it is obviously this discolored floppy drive here for 5 1/4 inch drives. However, again, major problem here in Oklahoma. We didn't have a whole lot of this stuff, especially during the time frame that they would have been using 5 1/4 drives. So finding one that actually matches here in Oklahoma is a little bit difficult. I would like to find one in either a white or an off-white color, such as this case. But yeah, this is just going to have to do for now. It's not even connected on the inside. It's actually just sat in there for now. I can pull this out completely. It's mostly just sitting in there for aesthetics because this particular drive doesn't even work. It's completely dead. It doesn't power on or do anything. So it's mostly just sitting in here to take up a place and to make it look fairly aesthetic. So I'm going to pause the video now. We're going to open this up and take a look at the inside so that you guys have an idea as far as what you might have to do when converting these things. Give me just a minute, let me tear everything open, and we will be right back. Okay, we're back. Now, the particular board that I have in here is a 486 board. I currently have a 486 DX processor in here. It's at the very bottom. It has 128 kilobytes of cache, and it has 8 megabytes of RAM on 30-pin modules. Now, we also have a Super I/O card here, which is giving us both serial port as well as parallel, floppy and hard drive, and also a LED indicator for the hard drive. We have a video card here. This particular one is a 512 kilobyte Trident 8900 card, and we also have a Snark Barker Sound Blaster 1.0 clone card in here. Now on the bottom I actually have a CF card. Well, it's actually a PC MCIA or whatever it is, PC card adapter. It's currently got an adapter in it with a CF flash card. However, I do not have this working at the moment. I need to get some drivers for DOS to be able to use that. However, the rest of it's pretty straightforward. We're just going to tear into this real quick. First, we're going to remove the hard drive connector as well as the floppy disk connector here. If I can get this out. We're going to tuck these up under here so that we can actually see. And here we have our light indicator for the hard drive, just to show hard drive activity. We'll tuck it back over here. Actually, let's kind of put this in here just so that it stays out of the way. Now, this case is pretty nice because it has both an intake fan as well as an exhaust fan. And it is a little bit loud when it boots up because these fans are drawing a lot of air, but I wanted to keep those intact because this particular motherboard, the 486DX, actually gets pretty warm, and that cool air going across it really does help to cool it down. Now the center of the processor is still too warm to touch, but you can touch the outer edges and it's cooling down by the time that it's sinking the heat out to the ends. So I don't think it needs a heat sink, but having this fan here blowing across it and this fan exhausting that hot air out really does help. Now, we do have a couple of wires connected up here. One of them is obviously the reset switch. We have the piezo speaker, and we also have the power light switch that will go to the front panel. As mentioned before, though, it's kind of hard to get in here and see, but let's see if I can reach back here and find it. We've got the two green wire, or the green and black wire right here, that are actually it's zip tied up in here for cable management, but it does go to the green and white power switch wire that I've actually connected to the front of this, and that allows us to turn this on. As a matter of fact, I will grab a power cable real quick and show you that this does in fact work. Okay, so if we boot this up, as you can tell it's working. We should hear a beep. There we go. And if we had it connected to a VGA source, we would be able to tell that it is in fact working. We don't have anything booting up at the moment because we have disconnected the hard drive. However, it is in fact booting. Now we can also reset this just like such, and we should hear a beep again here momentarily. There we go. So it's working. The power supply latches because of that latching switch that we have. Now the next thing that I want to talk to you about is I/O cards and hard drives and things of that nature. Many of these AT boards, they did not have hard drive connectors on the board. That is something that we didn't typically see until the Pentium era. So you will want to make sure that you have something like this, which is a Super I/O card. Another example of a card such as this is this one here. This one is a WinBond card, and this one here is just a generic based on a HMC chipset. But most of them have a floppy disk connector along with a hard drive connector and a hard drive light connector here. They typically have 2 serial ports, a 15, well it's actually a 16 pin connector here, but it's for your DB15 gain port, which you can disable on most cards, and it also has a parallel port. Now you have to have one of the I/O brackets with the cables that come over and connect into these. I've got one, I just don't have it in here yet because I'm keeping these two, well, this top bay empty because I do have a backup battery installed, an external backup battery, and I'm wanting to keep a couple slots here open in case I decide to add in some other card in the future. Now, speaking of the backup battery, there's a couple things here that you need to think about. The batteries on AT motherboards were typically soldered on, and they are terrible. The problem with them is that they leak and they corrode the board. As a matter of fact, let me grab this other board. This is a good example because I've been repairing quite a few of these. You can see quite a bit of damage to the traces in this area, and even if you flip over you can see where there's been some corrosion in this area. Now that said, a lot of times this requires some repairs to get it back functioning, and I've got a video that I'm going to be doing here shortly on those repairs and kind of how you do them. But long story short is that it can cause some real havoc, and so you need to remove those. Now luckily with the AT as well as some early ATX computers, they did have a 5-pin connect, or I'm sorry, a 4-pin connector that allowed you to hook up an external battery as well as a jumper that you can actually see right here, that when removed allows you to source current from that external battery. Now there's a couple ways of going about this, but realistically the easiest way is to, and you can barely see it here, but I've actually got a battery pack. It uses 4 AA batteries. You'll need to check your particular board, and if you can, find out what the specifications on it are. But most of the time this is going to be anywhere between 3.5 volts to 6 volts input. Now this one here actually supports 6 volts, and that's why I have a 4 AA battery pack. But you can actually use a 3 battery pack as well, and it will probably work fine. But you will have to make a custom cable here. I'll put a couple links down below to some articles that I found on doing this. And that's not the only way that you can do it. There's a couple other ways that you can do it. You could construct something like this, which is a little LiPo battery along with a little charging circuit here, so that you can wire this up to the connectors that were there before and actually have a CMOS battery that is going to charge itself, and so that you don't have to worry about doing it. Because if this battery ever gets low, what I'll have to do is actually open up the machine like this, turn the machine on, replace the batteries in this battery pack while the machine is on, so that I don't lose my BIOS settings. And the reason why that is important is because hard drives are also hard to come by. So I have in this particular machine a 160 gig hard drive. However, I can't address that much with this motherboard, so with the BIOS that it has on it anyways. So I actually have to use easy drive overlay software in order to be able to access up to 8 gigabytes of data. So you definitely want to make sure that that CMOS setting doesn't ever go away. So you're going to want to make sure that you have a battery in here that's capable of doing it. Now the good news is that once you have those batteries in there, you're probably not going to have to change them that often, because these chips source so little current that you're probably going to be good for years, at least months. So it's not that difficult to get in here and do it. And luckily with Easy Drive software, you can go in there and reflash just the software itself. Now you will have to reconfigure everything in your BIOS, but it does make it a little bit easier. The downside is it doesn't typically tell you whether or not the CMOS battery is getting low. But if your particular BIOS does do that, you probably want to go ahead and go through the steps that I mentioned before. But that's pretty much it for this build. I do have everything kind of up here out of the way so that there is as much airflow as possible. But with these older computers, once you get these floppy and hard drive connectors out, you're going to essentially block off a lot of that flow anyways. So it may be a lost cause, but I do like to try to keep everything as neat and tidy as possible, even though you just can't do it with these types of computers. So, nice short video today, just something overviewing how you can get by the problem of not being able to source proper AT cases. Obviously this is not going to be as period as it should be, but it is a beige computer case. It is fairly early ATX style. I think that this was designed as a business machine. Pretty good looking case though. It actually was pretty ugly. I'll try to stick some pictures at the end of the video so that you can see exactly what this case looked like whenever I got it. Because it was very beat up. It took a little bit of retro brighting on the plastic, as well as quite a bit of scrubbing and a little bit of magic eraser to get this thing back to where it needs to be, as well as quite a bit of wiping down and blowing out with an air compressor. But this is a good example of how you can get a computer that's an AT based machine, whether it be 486 or 386. Again, this particular model is a 486 machine. But if you don't have access to those types of things, like I do, you're in kind of a unusual situation where you're going to have to make do with what you have. And the funny part about it is I've actually been repairing quite a few AT motherboards lately. I'm only about 3 hours from Dallas, meaning that I'm actually fairly close to computer reset. And one of the local guys here in Tulsa, he's been able to break away 2 or 3 times at least to go down and pick up some boards and computers and things like that. And he's been very kind to allow me to go through the boards, and I've actually been very surprised. He's essentially brought over a truckload of parts and boards and computers and everything else and just said, pick through it and take whatever you want. And I felt like I was robbing the guy, I really did, but I kind of made a deal with him that I would repair some boards, let him have the pick of the litter, and then whatever he didn't want I would take. He's actually brought me a couple more AT style boards that I need to repair and let him take them, but he did do me a solid this last time and picked me up some 5 1/4 inch drives. Now they're all the 360K drives for the earlier computers. They're all black, and one of them is actually double height. But the interesting thing is they all appear to be brand new. They don't appear to have ever been used, so I don't know if they work or not. I need to stick them in my XT class computer and see if they work. But he's been very kind to me, and I've tried to return the favor by repairing some of these boards and get them back to him. I've currently got 3 boards right now that I need to start work on, as well as another computer. It's a Zenith computer, Zenith IBM PC class computer that I need to actually get working and get back to him, but it's got a lot of problems with the RAM card on it. Somebody appears to have robbed the ICs from the RAM card, so it can't access any memory and thus doesn't boot. But he's been very kind and helped me get a couple of the parts that I need in order to get some of these machines going. So I've tried to return the favor. But if any of you, just to make the video short, if any of you are having problems sourcing AT computers or AT cases and you have motherboards that you need to stick in them, hopefully this serves as an example of what you can do with a little bit of ingenuity and a soldering iron. You have to look for some parts. Like I said, I'm going to take the trouble of that out of the way so that you don't have to worry about it. I'm going to place some links down below. They are affiliate links, so they will benefit this channel if you decide to click on them and purchase them. Of course, I always appreciate that because I do this basically for free, and it helps to cover the cost of some of the components that I do, or that I use in these videos. But other than that, if you got something that you'd like me to take a look at, get in touch with me. I'd be happy to do so. We'll work something out, whether it's something that you just want me to do a video on and let me borrow, or something that you've got as far as a kit that you'd like me to do a review on. I'm always willing to do stuff like that. I like playing with hobby electronics, hobby computers, vintage technology. Not much into radio or anything like that, but I'm always willing to take a look at what you got. And again, I do want to thank all of you for staying around and viewing the video this long. Remember, I'm going to stick some pictures right after this video so that you can take a look at what this case used to look like in comparison to what it looks like now. And of course, check in next time. We'll have another video up here shortly. Alright, thanks. Have a good day.